Section 2.5, example 11, use a discriminant to find the nature of the solutions to a quadratic equation. Use a discriminant to find the nature of the solutions to the following quadratic equations. So first off, what is a discriminant? So in our quadratic formula, we have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So noticing this part here, we have seen two different scenarios. So we have seen this being a positive number in here, so a positive value. We ended up with two solutions because of this plus or minus, right? We also saw the possibility of this being a negative value, so a negative number. That gave us two complex solutions. So there's only one other scenario, and that's if this part is equal to 0. If this part is equal to 0, then we just have one solution because we no longer have this plus or minus part. So those are the three possibilities that when we plug our quadratic function into this part of the equation, we could see what our solutions are based off of what we get in there. If it's a positive number, then we have two real solutions. If it's a negative number, we have two complex solutions. And lastly, if it's equal to 0, then we have just one solution. So we plug it into just this part, and let's see. So b squared minus 4ac. Let's start off with this very first equation. Move this down to give ourselves a little bit of room. So here, we're plugging it into b squared minus 4ac. So b squared, b is 4. 4 squared minus 4 times a, which is 1, and c, which is 4. So 4 squared is 16 minus 4 times 1 is 4 times 4 again is 16. This gives us 0. So again, because we have the equation equal to 0, we've gotten rid of this whole part right here, leaving us with just one solution. So negative b over 2a. So this tells us we have one real solution. All right, let's see our second equation. So for this second equation, we're doing the same thing. Negative b, not negative b, b squared, 14 squared minus 4 times a, which is 8, c, which is 3. Just so we don't make any little mistakes. Let's see this. So 14 squared is 196 minus 4 times 8 times 3, 96. So that gives us 100. Again, we don't care about the value that we have here. What we care is if it's a negative value, a positive value, or 0. And in this case, it's a positive number. So automatically we say that we have two real solutions. So two real solutions. Do we have? Yeah, we have plenty of room. Let's check this one. So b squared minus 4ac. B in this case is negative 5. So negative 5 squared minus 4 times a, which is 3. C, which is negative 2. Negative 5 squared is a positive 25. 4 times 3 is 12. And then 12 times a negative 2 is a negative 24. So here we have +1. Oh, I lied. That should be plus. Negative times positive is a negative, times another negative is a positive. So this should be 49. So 49, which is a positive number, which tells us that we're going to have two real solutions. So again, the reason why it's real is because eventually what we end up doing is taking the square root of these numbers. Square root of 49 is a value, whereas up here, oh, actually we haven't gotten any of those examples yet. So hopefully we get an example like that here. Okay, let's shift. And b squared minus 4ac. B in this case is -10 squared minus 4a is equal to 3. C is equal to 15. And we have 10 squared. -10 squared is +100. Minus, we have 4 times 3 times 15. 180, which gives us -80. And because we have a negative value here, remember the square root of a negative value is going to be a complex number. Complex numbers always come in pairs. So we say that we have two complex solutions. Again, a little bit of a recap. When we take the square root of a negative number, we end up with complex solutions. So square root of a negative number is complex. Complex as in not real. So it's kind of like its own graphing system, its own group of numbers, of complex numbers. Another thing is when we take the square root of a positive number, we end up with some sort of value, even if it's a disgusting number, even if it's a square root of like 13, which is a decimal that keeps going on forever, we still have a value there. If it's equal to 0, this entire part gets lost, so we lose that plus or minus, so that it only gives us one solution. So those are the 3 different scenarios that we have when we throw numbers into our discriminant. If you have any questions, pretty please feel free to ask, and if not, bye.